Very good. It is 2 o'clock where I am, so I propose that we kick off the panel. First of all, I wanted to start by welcoming all of you to what is the almost last session of the online part of CAIN 2023. We have the panel and then the closing session. And then, of course, there are more things coming later on, but I thought that I'd refer to that. So I will play an as small role as possible. I just realized that I got the date on the panel wrong. It's actually May 16th today, but that doesn't really matter. What really matters is that we have 4 outstanding panelists that I think are really, that I'm really looking forward to hearing about. You've already heard 2 of the people. Ken did an outstanding keynote yesterday on autonomous driving in automotive. Futsu did a keynote this morning on reliable or trustworthy AI and the techniques around solutions to put around machine learning and deep learning models in order to ensure that we can trust the results. Of course, Grace was chairing the session right before this, so I know that you've all seen her as well. She's at the Software Engineering Institute. And then finally, our publicity promotion chair for CAIN 2023, Henry, is of course a well-known face in the community and has done a lot of work in software architecture for machine learning. So I'm really happy to have these 4 fine, examples of the human species to present with us as panelists today. And what I was hoping to share with all of you is that we have actually a quite simple schedule. This is my opening. I will end that in a minute. And then I've asked each of the panelists to give a opening statements that they can adjust to their own desires and length, depending on how they feel like it, where I've asked to do 2 things. One is to look back a little bit. What do the panelists or each of the 4 people feel is the best or some of the key achievements in AI engineering that have occurred over the last years? And then in addition to looking backwards, I was also asking the panelists to look forward and to identify what they see as the key research challenges that AI engineering will have to contest with in the time going forward. So, and of course, the intent is that this leads to a healthy interaction with the audience. I have asked the panelists to not automatically agree with each other. I would also like the audience to not automatically agree with the panelists, because that leads to a much more fun session. So with that, I would like to end my openings of the panel and invite, basically in the same order as I just presented, or they were on the previous slide. I would like to ask Henry to open and share his view on the questions that I just raised. So Henry, please.
Okay, so thank you very much. Please allow me to share just one slide that I prepare. I think it's visible over here.
Yeah, now it is.
Okay, so let me try to remove all this zoom. Okay, now it's supposed to work. So, okay, so hello everybody. Good morning or good evening, depending on where you are. So as Jan was already introducing, I've been working recently on this kind of figure that we use for running the software architecture for a machine learning workshop that was run for a couple of editions, and we are preparing for the next one, where looking from a software architecture perspective, what we recognized at that time, that the big question was how to relate these 2 blocks, one in the left and the other one in the right. So on one side, software architecture for a software system. On the other side, artificial intelligence and machine learning, and how to bring together, those 2 disciplines. As you know very well, some of the difficulties that we encountered also in some interaction with companies, is that those 2 communities talk different languages, sometimes use different methodologies, and they use different tools, different processes. That's really the challenge, and what is, in my opinion, very interesting to continue to investigate. More specifically, what we've been doing is on the left part, trying to understand how to use machine learning to improve runtime architecture design. So how an architecture, which is not just static, but that can change over time, can benefit from predictions that come from machine learning or reinforcement learning, so that we can optimize the quality attributes related to the system running according to our architecture. And more recently, we are investigating green AI. So essentially how to try to understand on the other side, so more on the other kind of block. So given AI, how we can make it more energy efficient. And also another thing we are investigating are patterns for microservices and green. What I noticed today, and especially yesterday and a little bit today, what I was trying to reason is, if I look at these 3 blocks, what we from CAIN are doing. I may be wrong, but I'm perfectly fine if you can demonstrate it to me that I'm wrong. What I notice is that many papers or topics, let's talk about topics more than papers, in my understanding, fit into this block. This block for me means that we use what comes from software engineering. So let's generalize a little bit, software engineering practices. And we use what we know from software engineering into the AI community. So here there's a high missing. I'll add it later. Okay. And I saw a lot of topics, deep learning training, COSML, hyperparameter, bugs in neural networks, quality requirements, and so on, that in my understanding touch upon the AI. So it's very focused on AI components, let's call it this way, and try to see how to improve, let's generalize the term improve, those AI components, the development, engineering of those AI components by using technicalities or software engineering practices. On the other side, I noticed, in my understanding, less numerous topics on how AI can improve software engineering. So looking from more a software engineering perspective, how can we use AI models and training methods and different kind of learning in order to improve the design, how we design system, how we test the system, how we apply our traditional software engineering methods using AI as a tool. Last thing that I noticed that there are, again, in my understanding, also some work that has been presented, which are more on the bridge. My understanding is that for the first 2 things, one helps the other one and vice versa. So we bring knowledge from one community to solve problems from the other community and vice versa. And some papers are more an integration of, the 2 things. Going rapidly to your question, Jan, achievements, I think that also based on what we have been discussing today and yesterday, we know much better which are the challenges, which are the limitations, which are the difficulties. Probably we still, didn't spend enough time because we wanted first to understand, as is usual, to understand which are the solutions to the problems that we were talking about. The challenge, in my understanding, is that it's not only looking, one community to the other one, but try to see how the 2 things can be incorporated together. And I've seen today some nice presentations and some papers more oriented on each other benefit, where whatever we know from software engineering can improve AI engineering, and what the people are doing in AI can be used as a good model to improve our software engineering practices. But I still see, in my understanding, that this is still a limited part, and we may want as a community to invest more on this part and give more importance to this, really linking the two communities so that we can talk together and we can realize AI related system, or a system with AI components. So this is just my few minutes introduction, as you were asking.
Wonderful, Henry. Thank you very, very much. And I recognize a lot of what you have on the slide also from the presentations that we had today. If we follow the way in which I presented the panelists, then Grace, would you be so kind to share your view before we dive into discussion? I can't hear you, Grace. So are you muted still? Can anyone else hear
you? No, not me.
I can't hear either.
Maybe you're using some Bluetooth, Grace, devices that is taking, because we see that you are not muted, but we cannot hear you.
If you use the Zoom app, there's an upward arrow next to the microphone. You can pick your... Nope, still not. I guess there's a machine learning algorithm that went haywire. Grace, shall I ask Ken to go first, and then you come back to us? Very good, Ken. A little unexpected, maybe, but if you don't mind, I'd love for you to take over where Grace was going to step in, but we'll invite Grace after your introduction.
Yeah, of course, happy to. Thanks, Jan. Okay, so I've been thinking about the evolution of the WAIN and CAIN conferences over the last 3 years in answer to your question, Jan, and asking myself, well, what do I think has changed in the last 3 years of the conference series? So within that specific context. And for me, I'm thinking about it in the context of areas that specifically affect my work and research. So the first area is obviously in the domain of machine learning. Even in the last 3 years, we've seen a dramatic increase in the pace of innovation in machine learning. In practice, not just in research, we've evolved from convolutional neural networks to graph convolutional networks to now transformers are the flavor of the day when it comes to machine learning models. And they're not new by any means. So transformers emerged as an exciting architecture about 6 years ago, but they've gained a lot of traction over the life of the conference series. And in particular, we've seen them evolve from a model focused on things like natural language processing and language understanding to transformer architectures in machine learning being applied to other modalities like computer vision or some of the sensors that I talked about yesterday, like radars and LiDARs and cameras using transformer architectures. And that's really enabling a lot of advances in how we apply and leverage machine learning in different contexts. So, seeing these models be developed in one context, be worked through different domains and being applied to different domains is exciting. And I've seen that reflected not just with transformers specifically, but with machine learning more generally in the conference series over the last few years. Second area that's really exciting for me is compute systems. I'm a software engineer, but I also am interested in the technology and platforms on which my software executes. And I try to have a deep understanding of, what are all of my options when it comes to running the software that I'm creating. So in the last few years, we've seen a dramatic rise in dedicated silicon. New chips have been emerging. So it's not just about CPUs and the latest version of a CPU from ARM or Intel. There's a wide variety of different processing options when it comes to choices about where to run our machine learning workloads. And there's been an emergence of new silicon, new system on chip technology. And there's been corresponding discussions in the CAIN and WAIN environment on things like FPGAs, for example, which has been really great to see in terms of relevance and understanding and moving the body of knowledge forward. The third area for me is, of course, software engineering. And for me, I enjoy seeing an increased focus in how to build systems more effectively and more reliably. For me personally, when I first started getting into machine learning and AI more seriously a few years ago, I started, like many people did, I'm sure, with notebooks and with IDEs that supported various libraries. But going from that to building systems that scale and can be deployed in the world and are robust needs a solid foundation in the software engineering practices and principles that we've developed over the years. So there's two things in particular in software engineering that I am excited about in this. One is quality attributes. So we have a long history of things like understanding quality attributes when building large, robust systems. These things are still applicable, more so, one might argue, in the context of AI-enabled systems. So things like security, reliability, safety, predictability in our systems are still absolutely critical. So let's not forget that they are there and we know how to build systems like that. And the second is machine learning operations, or ML ops. So arguably a new discipline, but really building on top of long established practice in things like continuous integration and continuous deployment and DevOps. CI now has to incorporate things like testing and validating of data and models. We have to have machine learning training pipelines. We have to have continuous training of models, continuous retraining of models, continuous deployment of updated models, in my case, to vehicles and other test environments. But depending on what area or domain you're working in, all of this is applicable and beneficial. So then the next area I'll talk about is the evolution of domains. In the last few years, we've seen excitement around machine learning and software engineering grow well beyond application to systems that run in a web browser or on mobile applications. I'm excited to see all of this technology have a really strong impact on a wide variety of domains. Everything from biotechnology, bioinformatics, agriculture technology, wearables, fitness, undersea exploration, drones, aerial technology, and a lot of these domains are reflected in the conference series over the years, and including this year, which is again wonderful to see. Also, using sensors and machine learning and algorithms and AI to do things like, for example, map the Amazon so we can see what's underneath all of those dense tree structures in a non-destructive way, or map the insides of the pyramids or other ancient structures. Seeing this technology applied in the world to more than social media or more than getting clicks on ad revenue is, for me personally, exciting. So it's great to see all of that. I'm personally excited about autonomous vehicles and robotics, of course, and I truly believe that some of the most exciting developments in machine learning and software engineering are happening in the world of autonomous driving, and we have a lot of big and interesting challenges to solve, and we're continuing to do that. It's also forcing, all of this evolution in technology is also forcing some wonderfully existential conversations at a wide scale around the world, and creating awareness of the possibility of the wonders of the technology and also the possible threats of the technology, which again is great that at a societal level we're having those conversations, and my hope is that through conferences and media like this, we will move forward responsibly and deliberately and with caution, and continue to make progress. So summarizing my perspective on WAIN and CAIN over the years, then all of what I've talked about is reflected in the content of WAIN and CAIN. When you look through the programs over the last 3 years, WAIN and CAIN conferences have provided a venue for collaboration and discussion around these topics, and I appreciate the relevance to industry practitioners. have a history of working with academic institutions, both from a teaching perspective and research, but I'm firmly rooted in industry and look at this technology for how it can help me solve problems and ship products. And I find relevance in the content over the years to help me answer those things. I value staying current with the state of the art in things like machine learning and software engineering, and CAIN continues to offer a community and a forum that brings together great perspectives and ideas and research and experiences, everything from new perspectives on code smells and technical debt to systematic literature reviews on AI risk assessments, seeing insights from challenges that other people are facing as they build ML systems, looking at frameworks for machine learning model optimization. It's a wonderful mixed bag of content, and I'm already taking away lots of ideas that I'm excited to try from this year's conference. So my final statement, looking forward on your question, Jan, looking forward to key research challenges. The big one is just simply keeping pace with the state of the art. There are literally hundreds of machine learning papers per day, and I'm sure you're all familiar with the hockey stick graphs that show from like 2010 to 2023 the number of machine learning papers that get published every day or every year. It's very difficult, but having a community like CAIN that's curating and distilling relevant literature for me as an engineer is great. It's a huge benefit. Next challenge I'd say is for us as a community globally, don't throw everything out. We don't need to start again. We have tremendous bodies of knowledge from software architecture and software engineering that are highly relevant. We could cite anything from patterns or the fallacies of distributed computing or how to build distributed computing systems. All of these things are hard-won knowledge over the last 3, 4, 5 decades that are absolutely foundational to how we go forward in building ML-based systems. So fully agree with a lot of Henry's statements in his earlier opening around this. Then for me, big challenges are scaling systems that have an impact in the world. So dealing with enormous amounts of data. I gave an example yesterday of an autonomous vehicle, for example, generating 4,000 gigabytes per day of data. How do we manage and process and deal with all of that data in a meaningful and effective way? Developing safe systems, being sensitive to cost as we build systems. All of those are key challenges that I'm continuing to try to address through my work and research. That's my summary.
Wonderful, Ken. And you raised very many, very highly relevant points. But for me, one of the ones that has not been discussed so much yet, and I do think is a problem, is the phenomenal amount of research papers that is actually being published in AI. And how in heaven's name do we stay on top of that from an AI engineering perspective is something that is actually something I do not have clear answers for, but hopefully the audience has. Thank you very much, Ken. And now we're going to check if Grace has managed to solve her audio issues or if we're still struggling with a few things here. Uh-oh, I cannot hear you, Grace. Futse, it looks like you will also have the opportunity to speak before Grace while she goes and tries to figure out. And Grace, one might be that you log out and join again in order to maybe reset a few things. I don't know if that will work, but in any case, I recognize the slide, Futse, so go ahead.
Yes, so I just use some one of my main slides and use it to share my thoughts on what I think maybe is laying ahead of us. So I think one thing that our community have been doing well the past few years is first realizing the urgency of looking at engineering of AI-based system at something specific that require the attention of putting together sound engineering practice. And then we started having some early work, I would say some focusing more on the reliability part of the problems and specifying good and bad practices and so on. So that's where my team and some other colleagues have been mostly focusing, trying to build techniques to see how we can actually test whether or not an AI component behaves as it should behave, given that we don't have an oracle to test as a reference to assess the behavior of this type of component, building techniques to detect issues in the different artifacts that come in play when we're building AI-based system, both in the quality of the data, the quality of the model, the quality of the program itself. And I think that going forward, one thing that I think is also challenging and emerging is with the generative AI gaining more and more prominence and starting being deployed in product, then it poses even additional challenges. How do we ensure the reliability of a component that is built on with a generative model for which we have really no reference base of knowledge for assessing the validity of the generated content? So this is, I think it's an interesting testing problem that's if it can even be considered as a testing problem, given that we don't have necessary references. Although I see some initial work people trying to use some knowledge graph of knowledge base to kind of see if there's a way to check and guide this kind of component in a much more reliable fashion. So I think that's something that could be interesting going forward. But another thing that I think is very fascinating, and I think Ken already pointed on this, is more the deployment phase. So once we have the model, and then we're trying to build those modern systems and deploy them in production, currently there is a lot of problems that are popping up. First, if you just look at the deployment landscape, it's so diverse. So we're seeing more and more stack being proposed for interoperability, for adapting. We're building model from using different frameworks and different formats that we have to deploy on different targets with different resource constraints in different environments. So there is a lot of engineering that I think needs to come in place to support the development and the operation of this machine learning system in productions. I haven't seen much work yet on this direction, and I think this is a space that the community probably going forward will have the opportunity to kind of share ideas and best practices and help build as well tool support to help this. Another aspect that I see coming is the auditing. So responsible AI is everywhere nowadays, and then there is a lot of frameworks that have been proposed. Most of them mostly high level, to ensure that systems are built in a responsible ways. But if we are to really enforce responsible AI, we need to have mechanisms for auditing for these properties. And I think the only way to audit really for these properties is to have the tool support or the engineering practices to ensure that the systems are built following the requirement of responsible AI, and that we can also have mechanisms to assess the behavior of those systems to ensure that they comply with this requirement. So I think this is a space that probably the community will have to contribute more going forward to providing the tool support and then the guidelines, the frameworks for auditing and building this system. Another aspect that I haven't seen more work, I think it's the UX on those type of systems. We have seen how ChatGPT became so successful compared to other language models that have been proposed before. Part of the reason it's the engineering efforts that OpenAI put into building the tools actually, and providing an interface to this model and allow people to interact with it. So definitely there are probably best practices on how to build UX for this type of systems and how to make them efficient in a way that we can pro. So I think the UX part of this kind of system probably will have to take more space going forward as the systems are evolving. Another aspect that I'm particularly interested as well is the emergence of this large model generating codes and used into building systems. So I think it's profoundly affecting our job as software engineers, software developers, in a way that we may be interacting with some of these components going forward. And I think integrating this in the development cycle brings up a lot of challenges, both at the process level and also at the infrastructure and the practice level. So I think there is potentially a lot of work to do for our community to really understand how we leverage this type of tool efficiently and how we make the developed software development process more efficient and more reliable going forward with those tools. So those are just a few ideas that I throw here and there around the things that we've been doing, and I think some of those could be interesting going forward.
Thank you very much, Lutz. The only thing I was wondering is you have this arrow at the bottom which says time. Do you expect things to move from left to right, or is that an editing thing that you're...
For the time was mostly for my initial slide of the evolution and continuous delivery.
Right.
But then are probably, I expect them to probably loop around, I think.
Right.
I think we need progress on all of those, I think. Right?
Yeah, exactly. Because I mean, if I look, for instance, at CAIN's domain as autonomous drive, then auditing and certification are a big thing already today, from the best of my understanding. So I do agree with you that they are most likely going around. Wonderful. Thank you so much, Futsa. I think that this is a really wonderful set of topics to work with. And now we're going to try again. Grace, yes.
Please tell me this is working now.
Yes. Awesome.
Just
like frustration from all sides.
Yeah.
Huh?
What is it? Third time's the charm. Well, I mean, going last always has the challenges, like, oh my gosh, everybody already stole my points. So I've been doing research for a long time and I guess the general area of my research has been understanding how emerging technologies affect software engineering and software architecture. And yep, I've been doing this for a while, and I have to say that definitely AI and ML has been one of the ones that has been like the most changing and just revolutionizing everything and changing practices, changing the way we develop systems, for sure. As far as key achievements, I think that we've done we've started to understand what these challenges are. We're starting to provide solutions to some of these challenges, and like Ken said, and this conference has been a great venue for focusing on those challenges and solutions. I'm really happy about advances in specific, I would say, aspects of AI. For example, responsible AI, trustworthy AI, the recognition of the importance of focusing on bias, on fairness, on explainability, which are kind of like these new quality attributes in this era. The tools, there are so many tools, probably too many, right? But the creation of tools to support lots of aspects of the model development lifecycle, and this is going to get to my complaint, let's put it that way. And also looking at MLOps and in trying to fully automate that training retraining cycle. But I think that the problem, despite all these challenges, is that there isn't a ton of work in real engineering. I still find a lot of the work in the literature and sometimes in practice still very model centric. It's focusing on developing the perfect model and not on making that model production ready. And by production ready, I don't mean it's accurate. It's great. It's 95% accurate. Production ready means that a software engineer can take that model, put it in a system, and it works great. And so that is what I think is really missing. That's that concept of production readiness. And I think there are many causes for that, potential causes. One, as I was hinting during one of the presentations before, is that for the most part, you have model development takes place in data science teams. These folks are statisticians. They're great at their job. They're great at producing the perfect model, but they're not great software engineers. And then you have software engineers that are great software engineers, but don't really understand much about this machine learning thing. And I think sometimes that makes it worse is when you have data scientists doing software engineering jobs, or software engineers taking an ML 101 course and thinking that they can do this, and they can't. And you need both. So part of the problem with production readiness is that these two groups aren't working together the way that they should be working together. There's also a need to, well, not only to define what production readiness means, but to be able to communicate it properly, to be able to communicate expectations so that both teams are on the same page. So what I would like to see is more focus on production readiness, more focus on not only what happens, how do you develop the model, but how do you take that model, you put it into production. It's easy to integrate, it's easy to test. It meets all its system qualities, it scales, it like that aspect I think is what is really missing.
Excellent. I'm glad you got your audio to work.
Yeah, me too.
I'm pretty sure. Good. That were the opening statements by the panelists, and obviously the whole purpose was that you do a panel for an audience, allowing the audience to interact. So are there any questions, remarks, things that people would like to raise in the audience? It's still a little quiet. I hope that people would step up a little bit. But I do have, yes, Tenzin, go ahead.
I'm going to make the self-interested question, I guess. I'm really interested. I've asked a couple of the different presenters and opportunities I've had about certification, kind of related to trust, kind of related to safety. There was a couple of mentions on the sort of production readiness in these comments. There's also a couple of mentions about progressing through some of these different components to make us progress towards certifiability. What are we seeing as the sort of key challenges and maybe the most furthest down the path? Is it the autonomous vehicles industry? Is it the aviation industry? Is it medical? Where are we seeing that traction at the moment?
Yeah, I think that's really interesting. So Ken, I'm going to ask you to start, I think, because I think that seems closest to you. In my own experience, one of the companies that I worked with is Zenseact, which is a wholly owned daughter company of Volvo Cars, also building autonomous driving solutions. Their biggest challenge, as they describe it to me, is how do they deal with proving or showing that the model will accurately manage situations that have an incidence rate of once in every 10 to the 9 hours. So once in a billion hours, you will have a situation that is potentially dangerous, and you want to show, and Ken, this is my question to you, how do you deal with this? Because the point is, I mean, people may think like, who in heaven's name drives a billion hours? But if you have like 8 or 9 billion people on the planet and half of them have a car and spend 1 hour in a car every day, then once in a billion is basically 8 times a day, right? And that is already unacceptable for most people to adopt autonomous drive. Basically, it has to be much better than what humans can do in order to be societally acceptable. So maybe Ken, can I invite you to go first on this one?
Yeah, of course. So the first thing I'll say is this is not a solved problem. Where we are as an industry, as a society, is on a path to solving this problem. And I'll pick out 2 or maybe 3 key challenges because there are many of them. But in response to your question, Tanzan, and yours, Jan, I'll focus on a couple of things. So one is, and Jan, you were getting at this as well, I think, is model explainability, and Grace, I think, touched on this as well. How do we, if in a non-ML system, we can explain how it works. We can walk through the algorithm and explain how and demonstrate how the algorithm makes decisions. It's reasonably deterministic in a lot of cases. For a machine learning system using deep learning in particular, it is less straightforward, and the topic of model explainability in general is a difficult one. If you incorporate that into a safety critical system, to your question, that becomes the stakes become a lot higher. We need to be able to reliably and credibly demonstrate that the actions that our systems are taking are within safety bounds that we have defined and are adhering to. So that's number one. The second is there are standards and certifications. So Tenzin, I think you mentioned certification. There are certification bodies that govern in the automotive domain, things like automotive safety integrity levels. ISO has its safety, functional safety standard, or a set of standards rather. There's the Automotive Electronics Council, all of these sorts of things. But what's important from a domain perspective here is that those standards apply to vehicles. To motor cars, to automobiles. And one of the points that I made yesterday is that when we're thinking about autonomous systems that are in the world interacting, where they can come into physical contact with people and other objects in the environment, we need to think about these not just as automobiles, but as robots. So we think about these systems as autonomous mobile robots that are interacting with the world and with the environment. The danger is if we treat them like vehicles, we'll apply standards for how vehicles should operate, when really autonomous mobile robots have a much wider dynamic range in terms of potential behaviors and therefore potential harms that they can inflict in the world. So we need to approach developing these systems with a safety first mindset, and that it brings in challenges not just with certification, but with engineering processes, testing processes, all sorts of things. But we got to remember, we're not just testing a vehicle, we're testing an autonomous mobile robot. Then your third element I'll note is, I think, Jan, you were getting at something like, provability. How do we prove after the fact that a system behaved as intended? So within the context of something like a safety critical system, like an autonomous mobile robot, or whether it's a drone or a underwater vehicle or an on-road vehicle, we do need to maintain safety logs and safety records separate from, let's say, the normal event logging or application logging of a system. So in the US, for example, there's regulatory bodies that can reasonably ask by law to inspect your safety logs, so that you understand vehicle behavior, not just in the context of, hopefully it'll never happen, but not just in the context of an accident, but just to prove that vehicles are roadworthy. So there's a lot of different mechanisms in place to deal with the topic that you've raised, Tenzin and Jan.
Great. Any other of the panelists that want to jump in on this one?
I can. So one thing that it's important to realize, I mean, safety. Once again, going to production readiness, safety is a system property. It's not a model property. It's a system property, and this is one of those things that, to me, it's the same as any other safety critical system that we ever built. We have to build in safeguards. We have to build in mechanisms for when something fails. Okay, the system stops completely. It's really a system property. So you can certify a system, a component, whatever, but in the end, it's a system property. That's one point about it. The other thing is that this might not be a safety critical system per se, but if you look at what banks do, and now that banks are getting into model development and using AI to make decisions on a lot of their things, for example, detecting as if a check is going to bounce or not, or are trying to predict if a client is going to overdraft. Is this idea that they have model risk management groups within their organizations, where basically they look at models and they say, okay, what is the risk of a false positive? What is the risk of a false negative? And how much risk can we live with? And then basically what you do is, once again, a system property, you build your system around that boundary and say, okay, it seems that this is the potential area in which I can move in. And once again, anything that falls outside that, immediately do something about the system. So even in banks, it still is a system level property where you have boundaries, and you're really trying to understand when it's going to fall outside of that boundary.
Yeah. I think that's a great point. Sorry, go ahead, Futsen.
No, I mean, I wanted just to double on this, right? So that's why testing, verification, validation is very important, right? In the sense that although these machine learning theses are imperfect, but if we test them enough, in the case of autonomous system, usually is through simulations, like software in the loop type of approaches that is being used. We try to emulate as many scenarios as possible, corner cases, and once we understand the boundaries in which we have a good understanding of the behavior of that component, then we have to build safety guardrails around the component to ensure that when the system that is built using the component can emulate safety properties that are desirable, that need to comply with the regulation. So although the component may look imperfect, but I think in a system engineering perspective, it's a bit a similar process as building a safety critical system using even a symbolic component around it.
I think that those are great points. And what I felt was Justice was doing a presentation in the session that Grace chaired, talking about design patterns. And one of the patterns is you have rule-based systems around the machine learning or deep learning model where you have predictable behavior. So I thought that was a really interesting one. And both Grace picked up on something that also Henry raised, which is we have a whole body of safety critical engineering, which of course we have to rely on when we do these kind of things. I think that that's important. We should not try to reinvent the wheel from scratch. The one thing that I wanted to mention is I was at a company in the medical domain, I think last week or the week before, and they were using machine learning to do image analysis on images that come out of microscopes. And then I asked them, how did they deal with the certification problem? And they said, no. What we do is we only present the analyzed images to the human, and then the human has to assess whether this is correct or not. And that is our safety check, because then you can put the responsibility on the human rather than on the machine learning algorithm, which of course works great in systems where you have a slow feedback loop, but not so well in self-driving cars or those kind of cases where the human would never have a chance to respond in time to anything that might happen. But where you can, I mean, you may, and this is Princess Grace's example about banks. I mean, fraud detection is one of those use cases where machine learning is used a lot. Rather than immediately blocking things, typically things get escalated to humans as anomalies, and then humans have to make the final call on if something is indeed an anomaly or something else. So I think that there are tricks, but if we go to the most extreme systems like autonomous drive, where you cannot afford to have a human in the loop as a kind of check, things become a little bit more tricky. Especially with the very low incidence cases that you have to deal with. Tenzin, do you feel that you got your money's worth, or do you feel that we were just talking around the problem?
No, I think this is very good. A lot of that is my similar experience. I have the job of trying to figure out how the Australian government is going to think about certifying in an aviation context. So just trying to get a sense for what everyone seems to be doing. Most people seem to be working on the same trajectory. I think Ken talked yesterday about ISO 26262, and there's a bunch of similar things happening in that space, similar in aviation. I think maybe it's a little bit further behind, but it's good. Thank you.
Yeah, but it's a little, okay, I'm going to be going out on a limb here. And I think the problem in aviation is a little bit easier than in autonomous driving, because things don't move that fast. And by the way, I have understood that Australia already has fully autonomous trains, so you have at least a bit of a track record to build on, is my understanding. So, but good luck with that, Tenzin. Ipek raised her hand and turned off her camera at the same time. I'm not sure if that was intentional. Oh, there she is. Go ahead, Ipek.
Can you hear me?
Yeah.
Perfect. So I'll start with Henry as a question, but this is to all the panelists, but in fact to all the audience as well. And you brought up the point in terms of what is it that we're focusing on in CAIN, where there's the component where there are all sorts of engineering techniques going to the development of that. Like there's some of them are very complex, algorithmic. There's those interactions, and there's the AI engineering, software engineering. Obviously, this is not the first time where we want to open up the components. Like we look into services, we look into different elements. Like when we look at the patterns, we look into intermediaries, how they work, what are the responsibilities. When it comes to the models and AI components, we're a little bit more cautious. I think the techniques go between math and computer science and everything in between and machine learning. So where should this community stand, I think, is a good question. Not just for CAIN, I think it's a software engineering question, but what are everybody's thoughts on that?
Yeah, I can tell you what I was thinking, Hipek, when I was preparing the slide and also discussing with some of you yesterday during the conference. I hear a lot about auditing ML, testing ML, verification and validation of ML, okay? I honestly don't listen enough about auditing with ML, testing with ML, engineering with ML. It looks like that we are so preoccupied by that specific component, let's call component, Okay, and I understand why, indeed, because it's a new one. It's the one that is with more uncertainty. But we are focusing so much. Maybe it's natural, but on doing things for ML instead of using ML as an instrument for doing software engineering better. So that's what I wanted also trying to put in this slide, in my understanding. And again, I understand the why, but we need to be careful. And also I think that something that is very important, I was thinking to the testing community that I've been participating for a number of years and still following a little bit. I feel that one of the main problems that we still have in that community is testing in scale, which is one term that CAIN was using before. Okay, so I think that as a community, first of all, we need to understand as soon as possible how to use all these solutions and to apply to real projects at scale. Not just little things that we discovered in 10 years that will, it works only if we take a limited system. It's also probably related to what Grace was suggesting before, because we tend as a community to say, okay, let me make a super perfect method that works on a little scale, a case study, or a very ad hoc system. And when everything is perfect, I try to, to expand to a bigger system. But then so many things change that when you apply to a big system, it's already 5 years later with tons of new problems to be solved. I think we may want to learn a lot from what we didn't do perfectly in software engineering, okay, and try not to make the same mistake now that we are dealing with this much bigger communities integrating machine learning and software engineering things. So that's what comes into my mind, that we shall be able to learn before making again a similar, let's say, mistakes that we've been doing in the past.
But maybe I want to jump here because is it true that we are not using machine learning for software engineering? I think when I look at all the other conferences, software engineering conferences, there seems to be completely overrun by machine learning based papers. Most of those trying to use machine learning for name it, right? For anything software engineering that we're doing. Then are we doing it the right way? Then at that point, I think maybe we can question whether or not we're leveraging machine learning in a more efficient way. But I think most of the community is trying to do this, especially in the testing community. Machine learning is being heavily used to optimize the testing process, right? To select best test cases, to explore the search space more efficiently, to optimize the search for the test input, test data generation, and so on. Large language models recently are used for pretty much everything, for program repair, for generating fixes for defect in systems, and so on. I think we are doing it, but the question is, do we want to be doing that maybe at CAIN? Maybe that's the question that you're raising, Henry. Or should CAIN focus on the engineering part of systems that have machine learning?
That's a good point, and I agree with you. I mean, my understanding is that CAIN is focusing so far very much into the other direction, and testing is one example. As your presentation was clear, that in fact your presentation, in my understanding, was quite different from many other presentations that I heard yesterday in CAIN. And I agree with you, and we were discussing a little bit on where should we focus more.
You're mute, yeah.
You're muted, yeah.
Yes, even Zoom informed me that I was muted while I started to talk. I wasn't sure if we were talking about CAIN or if we were talking about CAIN, but because I got a little confused here. But it was CAIN that we were talking about in this case, right?
Yes.
Grace, Ken, do you want to share anything? It looked like we lost. Oh no, Ken is still here. Anything else you want to share?
Yeah, so just adding on to the points there in response to IPEC's questions. One thing that stands out to me is that as an engineer, we're good at building tools to solve a problem, and that can be a blessing and a curse. There's a lot of tools. So when I think about the particular area that IPEC raised, I think about what's useful for me in the work that I've been doing for the last few years is tools that provide more insights, development tools that offer some runtime support, profiling, dynamic analysis, those sorts of things are really important to understand the behavior of systems in general. But now with the introduction of AI intensive software systems, they become even more critical and even more challenging. So I like the Unix philosophy to tool development, lots of small tools that have a particular focus and do one thing well, and we can combine them to do many things. In general, tools that help increase the reliability of our systems and the productivity of our teams, and the safety of the products that we're creating is a good thing. But it is a challenge, and two particular challenges I'll note. One is just awareness of all of the tools. Like with the discussion we had earlier on the proliferation of ML papers, there are so many tools for different things. So that leads to the second challenge on specificity versus generalizability. So we could talk about tools that offer model insights in a software engineering environment, but a tool that I might use in a banking environment or a healthcare environment might have very different constraints than a tool that I need in an autonomous driving environment. So something like a compiler is a very nicely generalizable tool. Most companies are probably using the same version of GCC unmodified. But when we get to more specific problems, more specific challenges, more specific contexts, it's good to start with more specific tools that are solving dedicated problems and see what we can extract from that. And that's where something like the CAIN conference can provide a focus as well, is helping to understand the context of the problem we're trying to solve in specific terms and extracting generalizable patterns.
I think that was a really good point, Ken. We always refer to our own research results and our own viewpoints based on the context in which we operate. And we tend to very easily generalize what we're doing, assuming that everyone else has the same problem. And what you're basically saying is, and I think it goes into the line what Futsu was saying, that there is a kind of an explosion of tooling. Yeah, it's kind of let 1,000 flowers bloom.
Yeah.
But I do agree with you, and I want to reinforce that point. Start by solving one problem well, and only then start to generalize what we're trying to do into a broader scope. I mean, from automotive to embedded systems to maybe broader, but don't try to solve a too broad problem, because I don't think that we will be able to do a good job. I have a problem now, because here's the challenge. Kartik raised his hand first, then lowered it, then Helena raised her hand, and then Kartik raised his hand again. So I'm now not sure who's actually first. So Helena, do you think you should go first, or do you think Kartik should go first?
I think Kartik was first.
Good. Kartik, it's your question. Go ahead.
Wow, thank you so much, Helena. So yeah, just wanted to add on something to what the discussion has been going on. So this is some question that I've been asking around to people in the community, even through the architecture conference. So if you look at software community as a whole, right, we have been doing a lot of research, we are writing papers, we are referring our own papers, and it is going on. On the other side, communities like machine learning, today when we see GPT, it is not something that was invented today, right? It has been through a lot of research that has been happening over the years on RNNs, then transformers, and finally we have reached GPT. So when we look at software community on the other side, we are doing research, but at the same time, I see there is a big gap in what the industry is doing, right? So industry is going somewhere else and we are going on the parallel track. And we often try to catch up with industry. So industry introduces a jargon, says, okay, we are doing serverless, so every research starts doing serverless. But by then industry has already moved to something else, right? So now we are in this community of AI engineering. So do you think, can we do something that the industry needs? Start doing something where the research can be more intensive and exploratory, and that can contribute back to the industry before the industry starts dictating the jargons. Yeah,
I think it's a really good question. It's kind of interesting because I see tons of papers on microservices these days, and actually now the trajectory has swung back from that, and people are moving much more to monoliths and moving away from microservices. But as a research community, we're still very actively pursuing microservices as if it's the best thing since sliced bread, right? So I think that that's a very fair question. I'd love to hear our panelists comment on this, but I don't know who wants to start.
I can start.
Hmm?
So I think I'm going to combine Ipek's question and Karthik's question. So I think in CAIN we do really have an opportunity of taking a system-centric look at how we develop AI-enabled system-based systems, AI something systems, as opposed to model-centric. There are tons of conferences out there that are model-centric, and some of them are huge. So I think this opportunity that we have of really focusing on the system, on doing the engineering is great. And I think how it ties to Karthik's question is that this is something that industry is struggling with, because we see it in our work, is that they're just now learning how to develop models and how to get it right. But when it comes to integrating them into larger systems, they are indeed struggling. And I think this and the time is right. I think that focusing on the system level aspects of AI enabled systems would be great for the conference, and I think it would be a good contribution to industry.
Yeah, I agree. I think this community can contribute things like best practices, patterns, and so on. Right, like looking at the system view, how would we integrate this component? If we can come out with processes, practices, well-evaluated practices, maybe tool support. Like, I think we can contribute back to the industry, because currently in the industry it's a bit ad hoc the way. Like some companies are doing in certain ways, some others are doing differently. There's a lot of efficiency issue going into deploying these systems. It's very expensive in terms of resources. They are having performance issues. They are having scalability issues. Some of the problems they are trying rediscovering have been researched in the software engineering community for many years. And I think we may have an opportunity there to adapt to the new context and the new workloads that they are dealing with, and come out with something that they could actually adopt back in the engineering process of those systems. I think.
Great. Any other panelists that want to jump in? I think, Ken, you were looking to jump in right before when Grace started.
Yeah, thank you, Jan. Yeah, so Karthik, your question sparked some thoughts on this. So I'll summarize it as I try to be actively involved in both ML research and software engineering research. Software engineering for much longer in my career than the ML. So my perspective might be biased just because I feel more aligned with the software engineering community. But I see it from a couple of perspectives, and just sparked by the way that you asked the question, I found that really insightful. So the first is so my thoughts will not be so insightful as your question though, but my first thought is when I look at the ML research, it tends to be driven more by curiosity and exploration, whereas software engineering research tends to be driven more by solving a problem. So that's the first. Yeah, that's the first thing that strikes me. And yeah, and you mentioned microservices, and we could associate that with like cloud native and everything like that. Even those things emerged from industry as responses to real and practical problems. How do we scale systems? How do we get content to users around the world? How do we create independently deployable artifacts? All of those sorts of things, and more led to solving a particular problem. Whereas if we take something like the evolution of GPT that Karthik mentioned, at least my perspective is it was driven by, maybe hopefully a desire someday to solve a problem, but driven initially by a curiosity to explore and to see what we can do with processing language models. The second thing is accessibility. It feels like some of the big, in quotes, headline items in machine learning research, like language models and transformers and GPTs, are at least initially when they come out, are less accessible to the general community of practitioners and researchers. They require billions of dollars in investment. You see the names associated with them are companies like OpenAI and DeepMind and Google, companies with very deep pockets, and that brings its own risks as well. But I'll focus on the accessibility piece. The average engineer or scientist with limited funding and limited time doesn't have the same accessibility to the current state of the art in those things. Whereas my perspective on software research is it's always been more accessible. If I've got a problem as a software engineer, I have an amazing variety of tools at my disposal to go try and solve that problem. And I've got an amazing body of knowledge over the last 4 or 5 decades available to inform me about current thinking in any given area. So curiosity versus problem solving, and accessibility versus not accessibility. And I think we're at an inflection point with all of that, of course, but just for right now, that feels like where we're at.
I think it was very astute. Henry, you want to?
Yeah, from the CAIN perspective, I think, I mean, you have been participating to the software architecture community, and you know some of the limitations. I think that we should bring some companies into the conference, honestly. And because we already studied and we saw before from Grace and collaborators, what practitioner needs. And it's a variety of so many big things. So if we could get a few companies, I'm not saying many, but 1, 2, 3 companies that come and tell us, this is what I don't know how to do. Okay, can you as a community, as a goal for the next year edition, for example, come with a solution and work with us? I think that this may, be a simple tentative that may work. Because if we instead continue to focus on our brilliant ideas, on whatever we think that is our own idea, then companies, the only way they have to do is to solve their own problem, alone. So that's, since we are young as a community, I think it may be the right time to think about not just an industry track. Okay, I'm not talking about an industry track in a traditional way, but really to bring a few companies that we talk and we know that may want to collaborate and have some issues, and say, okay, come and distribute to the community your issue, and let's see what the community can do with you. And this will have the benefit, if we can do it now, that the problems will be still quite, in a sense, easy for a research community, not too, let's say, fine-grained, that if we start collaborating now and not later when the problem will be so specific that, really may interest only a few people in the community, maybe we can create a culture, because I think it's a matter of a culture of problem solving, as Ken was saying before, of problem solving together with company. So that can be my suggestion, looking at from a conference perspective.
Awesome. And now, Helena, now you gave Kartik the opportunity to ask his question first. 15 minutes later, it's finally your turn. So go ahead.
No, I am happily listening in, and I think this is at least to some extent related, and I want to connect back to yesterday. I think Ken had a beautiful quote in the very end of his presentation where you said that for an autonomous vehicle, no road is the same 2 days in a row, which, by the way, is not really the case for my car, but that's a different story. But those are the new challenges with the sensors, the data, the algorithms, the model, that whole new. And then we have what was referred to as the old challenges in the most recent session, where Nadia presented a paper where they had identified challenges also with regards to the things we sort of already knew were difficult. And that becomes even more problematic now in this space. And she mentioned in particularly requirements engineering and architecture. And I guess I'm a little curious to learn a little bit more about the relationship between the two, so the new and the old. And so the question would be, what, as a few examples, what can the new learn from the old, and vice versa? What could the old learn from the new? When we now talk about, let's use the knowledge we had as software engineers community to bring into this new world. So what can the two learn from each other? That I would be interested in.
So I don't know who wants to start, but we have 5 minutes left. So everyone gets 1 minute because I need 1 minute to close. Anyone who wants to go first? I mean, just to give you a few hints, I mean, Grace already mentioned the safety engineering community, which I think we are benefiting from, and we should not start from scratch. And on the other hand, I think it was Futse who mentioned that we now see that the machine learning is used a lot for instance, testing of software to help to optimize the selection of test cases. And there you have a situation where I think the way that we're currently doing safety certification of vehicles, or at least trying to do safety certification of vehicles, is driven by the principles that come out of the old safety community, if you want. But we're also using AI techniques to actually optimize our ways of looking at that problem. So at least that's for me is an example of where the new can learn from the old, and then the new, say between quotes, the AI part can learn from the old can learn from the new in that sense. So that would be one example that comes to mind for me. But everyone is looking at me as if it's really late in Melbourne right now, so maybe that is the case.
I can add another example of at least in one direction. One problem that I see is that a model in the end, it's a piece of code, but just like everything else. And unfortunately, the processes that are followed to build that piece of code are not the typical processes that are followed by software engineers. The process tends to be very ad hoc. That's a known fact. If we could bring some of that knowledge to let's call it to the data science pipeline, I think that would be a huge benefit where that community is benefiting from software engineers. For example, unit testing. For a software engineer, unit testing is, they can do it in their sleep. For a data scientist, that's not something that is something that is ingrained in their background. So I think that's an area where the new can learn from the old, just bringing plain old software engineering practices into that discipline.
Good. So in the interest of time, because everyone is starting to look a little sleepy, we didn't have to have this panel because I actually asked ChatGPT what the engineering challenges of industrializing AI is. And if you're curious, here's what ChatGPT has to offer. The tool is actually identifying 6 areas that need to be addressed. So there are several key engineering challenges involved in industrializing AI: data quality and availability. I think that's one of the things that, in my view, we talk too little about in the CAIN community, because all the companies that I work with are having huge issues with maintaining high quality data pipelines. Scalability, which has been mentioned, but I think is a very important one, because Ken was referring to this in his presentation, because he was looking into what are the different hardwares that I have available to deploy on, and depending on which hardware I use, I can get a lot more performance or a lot less performance. I thought it was also quite interesting with Jane's PhD student talking about drones, that how much can I squeeze into a small NVIDIA GPU that can still be integrated into a drone. So there we run into scalability issues. Explainability and interpretability. I think that's a hard challenge, that I'm not sure if that's a engineering challenge per se, but I think something that is quite important for us. Robustness and reliability, and of course Futse was looking into that, but I mean there are numerous examples where machine learning models exposed to a slight manipulated form of data come up with completely incorrect assessments. I mean, I'm pretty sure that you've all seen the example where we have a slightly processed image where a teddy bear suddenly is identified as a machine gun or as a gun or something like that, which is of course not a good situation. Security and privacy. Yeah, I like the fact that Ken brought up federated learning in his keynote. I think Futse had also a few references to it. I mean, that allows, of course, for data privacy in ways that we couldn't do earlier. And then the final one, human AI collaboration, which I thought was an interesting one, because many of these AI systems are not working by themselves, but they are actually working in interaction with humans. And similar to chess play, where initially it was humans that were best at chess, and then it was computers that were best at chess. It is now actually teams of computers and humans that are the best at playing chess. I think we will see many cases where this is the case in AI as well. So I will give every panelist 10 seconds to respond to this. Futse, we're going to start with you because you were the last on my list. So any quick reflections on this one?
What I think ChatGPT nailed the important points, not surprising. It's probably the most popular points on by the internet, and therefore in the corpus that serves to train the models. So I agree with those things. I think data quality, we don't look at it enough, and I think it's key actually, because the models really depend on what's come from the data, and ensuring the good quality of data, it's very difficult, especially the data is non-stationary, so it's changing over time. So we really need to have good process and practices and tooling. I'm a person, so I think automation is something that is important at that point as well. So I cannot agree with that.
Excellent. Ken, did you recognize yourself, or do you feel that ChatGPT got it wrong once again?
So I think it illustrates a wonderful example of where we need to be cautious as system builders in taking systems at face value. One thing we need to be cautious of is ChatGPT's knowledge base goes to November 2021. So these problems could have been solved in the last 2 years.
That was a wonderful statement. Thank you very much. I really appreciate it. Grace, you want to go next?
It's connected on the internet now, just for statistics. So it can search the internet.
It can search the internet.
It actually does not. It only uses anything. It doesn't use current knowledge on the internet. It only, I believe, it only uses knowledge up until end of 2021.
Yeah, in the model, but it can search the internet to enrich the problem. But that's
okay. Yeah. Okay. Good. I need to wrap this up because we are already cutting into the closing session. So Grace, any last reflections before we end up the panel session?
Yeah, I mean, the ChatGPT produced I would say system level answers, which is agreeing with what I said, but everything is, it depends. I mean, it's missing the human that determines, you know, the domain and what is more important than other things.
Yes. Okay, good. Thank you. And then last but definitely not least, our fearless leader from Italy, Henry. You're muted, You're muted, Henry. So
I believe what we'll be reading is a subset, and I agree with Futse that that's probably not based on, and also with Ken that it's not based on what maybe the very recent challenges. I didn't see, for example, anything there, but even we didn't talk about very much about, for example, uncertainties. That is one of the key elements, how to judge if what is generated is really the correct result, the oracle missing. That's, I think, it's one of the big issue that we even covered not so much probably during this edition of the conference. So maybe reasonable what we saw, but for sure not complete.
Yeah, good. Now, with that, I would really like to thank the four of you. I must admit, I wasn't sure if we were able to fill 1 hour and 15 minutes with panel content, but boy, we ran over and you all did a wonderful time. Really contributed to the success of this. So applause from all of us. Thank you very, very much for taking the time to contribute and to give the opportunity. Ken and okay, we stopped and started the recording because we're now moving towards the closing session. But all four of you, thanks a lot. I really appreciate it. And with that, seamless as always, we go over into the closing session. And I think Ipek is going to start. So Ipek, you know, I'm your remote control. You say next slide and I will jump.
I will. Well, First of all, thanks for bearing with different schedules, especially if you're in Melbourne. This was a blast for us, but we're not ending. I am hoping those of you who are in Melbourne are staying in Saturday and will be with us on Saturday as well. Next slide, please. But I know most of us have been waiting for our big announcements for awards. And we were very fortunate. We had really good papers, very good discussions within the program committee, and we could not narrow down beyond 4. So we said, okay, we'll put all these 4 to the second selection process. So we have 4 candidate papers. I'm going to read them all because if the authors are here, I would like to give them credit. Uncovering energy efficient practices in deep learning training, preliminary steps towards green AI, by Tim, Louis, Danielle, June, and Arif Anderson. Exploring hyperparameter usage and tuning in machine learning research, Sebastian Nicolai, Christian, Martin, Benno, and Norbert Sigmund. And trustworthy and robust AI deployment by design, a framework to inject best practice support into AI deployment pipelines, Andres and Jos. And last but not least, my colleagues from CMU, a meta summary of challenges in building products with ML components, collecting experiences from 40,758 plus practitioners, Nadia, Horan, Grace, Shuri, and Christian Kastners. They were all very good papers, but we can only crown one Best Paper Award, Distinguished Paper Award recipient, and that is, next slide, please. Big congratulations to Tim, Louis, Danielle, June, and Ari for their paper uncovering energy efficient practice in deep learning training preliminary steps towards green AI. Are they here? And more importantly, will you be there on Saturday? Do we have anybody representing? No?
I thought
Well,
I
we'll let
saw
them know.
Joost. I thought Joost was here, but I'm not sure if he is joining on Saturday.
Well, Ari, yeah, well,
Yeah,
I am here, but not in Australia, and I think Ari actually is there.
yes, Ari is here. That's right.
I saw
Yeah, exactly.
Ari's here, yes.
Excellent.
Right.
So let's hope that he joins on
Congratulations.
Saturday then. But congratulations,
And-
that's awesome.
So, all right, I'll find Ari and we'll let them know. But all the papers were very exciting to read, and we'll give the team from Netherlands their certificate. I think we have another award, which my colleague Helena will announce.
Yes, if you move to the next slide, we have also the Early Career Researcher Award in memory of a person who was key not only to this conference, but for the entire research community, Ivica Krunkovic. And so this was awarded to the paper that was among the papers that then received the highest scorings and rankings and came out from great discussions about the reviewer as the top papers. And it has an early career author as first author. And we have a winner. If you move to the next slide, the award goes to Nadia Nahar for a meta summary of challenges in building products with ML components. So big congratulations, Nadia. I hope you are maybe in the call. I think I know your co-author is in the call, at least one. But big congratulations, Nadia.
Applause. Well done. Very good. And then the next slide after this, and Ipek, do you want to mention anything,
Yes.
everything about this? Because CAIN is not over, just the online part is over, but the on-site part is actually not even close.
Well, we will have a normal conference in person with food, with coffee, and with conversation on Saturday. We have a keynote, we have local industry speakers. We have organized the sessions so that we focus on the conversations, and quite a number of you are registered for the on-site as well. So looking forward to seeing you there. I think if you're here at ICSI, you know the drill. And if you have any questions, find me around. And Henry is here, Grace is here, and we'll all be there. So, and we're very much looking forward to a very exciting day on Saturday.
Yes, absolutely. And because not everyone will be on the on-site event, we wanted to already now foreshadow what's happening in next year. So the plan is to again co-locate CAIN with ICSI, and next year it will be in Portugal, which is a little bit easier to travel to, at least for people like me who happen to live in Europe, than Melbourne. And so there will be an event next year. I'm also, so co-located with, it should say ICSI 2024, so apologies for the typo. But in any case, we're co-located with ICSI, and I'm also very happy to announce that we have a stellar team in place. Jane has agreed to be general chair for the conference. Grace and Henry, who of course were on the panel for a reason, so you could learn a little bit about their interest and their passions in the area of AI engineering, have agreed to be PC co-chairs, and I'm looking forward to that. And Henry, that tie looks awesome on you, so well done on picking that picture. I think that looks great. So I'm super happy with this. I mean, I was when Ivica passed away very unexpectedly last year, and we still all miss him. I had to take over as a kind of acting general chair because and stepped in that fashion capacity. This year I was the general chair, but I cannot be happier to give over the baton to someone much smarter and more experienced and better than me, in the name of Jane. And I'm also very, very confident that the PC co-chairs will do as good a job as what Deepak and Helena have done this year. So I'm very, very happy for that. We will have the normal tracks, technical papers, posters. Henry was already referring to industry talks. What I also wanted to mention is that we are on LinkedIn. Henry has been very instrumental in setting that up, and as well as on Twitter. I'm sure that you're all aware of that. But also since yesterday, although currently without content until Ankit gets off the plane and has a moment with the internet to get some stuff uploaded, there is a YouTube channel, Conference AI Engineering, where in the near future you should be able to find all the recordings from the last 2 days. And I hope that is a good source for your future reference to all the things that are going on in the conference. And with that, of course, I would like to see you all in Portugal. I added a few little pictures of what Portugal or what Lisbon can look like. I think it looks amazing. But this is also the point where I would really like to thank the entire organizing team, the keynote speakers, everyone who submitted papers, everyone who presented papers, as well as everyone who was involved in making the conference a success, for all their efforts. I will personally not be in Melbourne on Saturday, but for those of you who are, I wish you a very good on-site day, and I'm really looking forward to seeing you in Portugal next year, if not before that, at one of the other conferences. And with that, I would like to close the online part of CAIN 2023, and I wish all of you a wonderful rest of ICSI and all the co-located events that are going on. But thank you very much for me, and thank you once again to everyone else who was involved in the success of the conference. Have a great day, or sleep tight when you get to it, which is probably soon for some of you. And I look forward to seeing you all again. And Henry and Ipek, please share with us how the on-site part went after Saturday. Yeah? And with that, thank you all very, very much. And I look forward to seeing you soon again. Take care. Bye-bye.
Bye-bye.
Thank you.
Thank you, everyone.
Bye.
Thanks, everybody. Bye-bye.
Bye.
Thank you.
Bye-bye.
Bye-bye.
Thank you.